Hello everybody, this is Imanol Morata. In this video we are going to see how to predict the success in delivering milestones for the employees of a distribution company. The presentation will consist of two parts. In part one we are going to take a look at the client's assignment, an overview of the data. We're going to retrieve and clean the data, and we are finally going to prepare it to be fed to machine learning models, particularly binary classifiers. In part two, we will be discussing such classifiers, stating what is the suitable family of classifiers to solve this particular problem. Then we will perform some hyperparameter tuning, and finally we will make some adjustments and a brief discussion of the results. So without much further ado, let's begin with part one. Now in part one we get the data from the client, which serves it in JSON form. We need to clean and give structure to the JSON file so as to be able to put it in data frame. This is what we're doing here using Python's string manipulation tools. We can see we now have a data frame. The data has some information about delivery outcomes of some assignments for different employees. The employees are marked by the anon ID, which is an anonymized identifier, and we can see that the data has information on the employee, on the implementation of the business in the area, and also information about the past employee's performance. Now the second part is the data cleaning. We basically get rid of not a number and null values. We give proper format to different data types present in the data set. For that purpose, we distinguish different kinds of data: string categorical data, integer-like categorical data, continuous data, and datetime data. Here we are replacing not a numbers by other more suitable Python-like NaN values. Depending on the type of data, we are choosing different ways of replacing these not the numbers. You can see you have all the explanations and reasonings here written in the notebook. And when we do this, when we are finished with this, we can start preparing the data to be fed to classification models. The first part would be to separate the dataset between development and production datasets. The only difference is that the development dataset has the success label, while the production does not, because these are the instances that we need to predict. Now we can see that it is a heavy unbalanced dataset with a prevalence of 0.96. And the transformation we apply to the dataset consists basically in applying a one-hot encoder for those categorical variables, unless they are already binary, in which case we only replace by 0 and 1s. We do that here, put suitable labels to the different categorical variables. And finally, we reorganize the dataset to have it in a suitable order and store both development and production datasets in its transformed presentation so we can start working with them. Now, this leads us to part two of the assignment, which we are going to comment just now. We start by deciding which type of model we are going to use and how are we going to validate it. The model is basically going to be a random forest because it is robust with respect to unbalance of the data, and since the data has many different types which live in different scalings, it is best to choose this model because it is not affected by different data types. In order to have replicability of the experiments, we set a random seed. Now the first thing we do is to check which is the best positive probability score threshold to use. We end up checking that using the prevalence as a threshold is a good enough value. can see it here. Now for this particular threshold, we get a valence accuracy of 0.79, a false negative rate of 0.14, and this confusion matrix and this ROC AUC score. Now it's important to pay attention to the false negative rate, because since we are measuring delivery, we want to get as less false negatives as possible, because if we want to put resources in this, we do not want to have the resources put into people that is already meeting their assignments, so we don't waste any resources. Now, once we know that what is the suitable threshold, we test a family of different parameters for different random forest models in order to choose the best one. Now we end up seeing that the best model is that with 50 estimators and a pruning parameter of 10 to the minus 4. Now other models get similar results, but they are more complex, so we always choose to get the simplest model. Once we have chosen a model, we start predicting the unknown instances, which is something we do here. Now we can check that the unknown instances get a different prevalence than that seen on the training set, which is the one provided by the client. I mean, we don't have a way to check that these results are correct, but at least we would expect to have a very similar prevalence. So we are trying to adjust again this threshold in the training set to see if we can get a closer prevalence to that seen in the training set. This is what we do here, and this is where we can see that around 0.7 there's a threshold where the prevalence in the outcome is similar to the prevalence in the training set. Now we put 0.7, we get a more suitable, or sorry, a more similar prevalence, so we go with this parameter, and with this parameter we make the final prediction that is sent back to the client. Now we end the document by looking at what are the most important features in the dataset that allow for the random forest to get to a solution, what the model is considering as the most important features. We can see that here, and we end up plotting a couple of trees in the ensemble to have a look at how the model is predicting and deciding which prediction goes to each instance. Thank you very much, and thank you for your attention.